Hello everybody and welcome. Our topic is computer graphic with OpenGL library. So let's start it. I will use Xcode and Mac OS X environment. First of all, I'm gonna create new project and I will use Mac OS here and command line tools as my project. I will set up project name as ComputerGraphics OpenGL, and I use my basic language as C++, and I will store is in my folder in my local computer, and I'm gonna decorate it. Yeah. Actually, before we actually started, we need to add a couple libraries. This library is actually OpenGL library. OpenGL is basically a specification for any operation system, and for Mac, I need to go to Build here to link binary with libraries, and just find it here in the search box. OpenGL, yes, and I'm gonna edit it. Yeah, and I need a couple more libraries. The first library is called brew install glfw. That library is basically to create OpenGL context, define window, and handle user input from keyboard, for example. Yeah, I'm gonna to. Oh, sorry, that version, the library call is glfw, but version is 3, and now I already have already installed it in my Mac, but if you need, you can install. And second library, what I need to install is this library for actually interact with OpenGL, and that library installed called GLEO, GL. This library is actually for implementation OpenGL function, because OpenGL is just a specification, and that library is implement all functions for us, and we do not need implemented functions. And we need to install, and I already have installed that library, so I don't really need it. What I need to do, I need go to my build settings and find here search paths, and what I need to do, I need to add some headers and some libraries. So I need more libraries, and because I have only OpenGL framework for my operation system, and I need to add some libraries. First library, it's like Shift Command G and go to path. Yes, sir. Local, and here we have a folder seller, and the seller folder we should have probably glfw3 3.02 libs, and we can include first one here, and we're going to include the library called gleo, another Command Shift J, go to this folder. Here we find folder seller. Inside seller folder, we should have that installed library. Yeah, it's here. And we need to go to lib, and in lib just add this dynamically linked library. Open. Yeah. And now in build settings, we need to customize our search path. Sorry. Yeah, here we go. We need to include some headers here, and first header, it will be user local include. Next one, I need to fine-tune my terminal window. Let's user local seller GL include, here we go, the path for our GLFW library, and we need to include headers for GLEO library. And here we go, it should be include path. Yes, this is correct. And of course we don't need ls here. I need to remove that. I don't need it. Backslash in the end. And here is as well. Yeah. Okay. Just to make sure, let's run. Yes, it works. Yes, it works. Next step will be add some more code here and include basically the libraries. So let's continue. First of all, we need to include some C++ libraries, and we need to include, declare some constants. What we need to for our project. Yeah, first of all, I just make a comment. What is this? Here will be I will be use some standard C++ libraries as stdlibs. Next one, I need to include our GLEO library. So before I include, I need to define some macro. Find GLEO static. That means basically I will use static linking for that library. Fine. Yep. Next one, I'm gonna to include basically that library GL GLEO. Then I'm gonna to include GLFW. Include GLFW and GLFW free.h. Then I need to declare some callback function. We will use this callback function for handle escape keyboard from user. Yep, it's return void. We can use name k callback, and here's a signature glfw window. That is a pointer. Let's name a window. Then int k int scan count int action and int mod. So here's our signature. Next one, we need to define window size. Window size. Let be a const. GLU int which 800, sorry, and height 600, and I'm gonna use namespace std. And here I ready to write actually code in my main function. First of all, I just make a comment for future reference. The game function. I prefer that style, and let's make for standard output cout starting GL fdw context and line. Yep. Then I will init glfw basically. Simple function glfw init. Then I need to set up few options. Set up glfw option. So glfw window hint, and basically I need 5 options here for my Mac. For Windows machine it could be different. Yep. So what I need to include first, I'm sorry. Here will be glfw context version major. Yeah. That's number 3. Then glfw context minor, that this will be also version 3. Then glfw option open GL profile, yeah, if I write here, and glfw open GL core profile. At the end of that lesson I will include the link for GitHub repo, and you will see all of that code. Next one, GL. That option basically is also only for Mac machine, as I remember. fw open GL forward compat GL true, and last one glfw release it gl false. Okay, now we're ready to create actually a window. Create glfw window. Okay, let's do it. The return type of glfw window, that is actually a pointer. Window equal glfw create window, which we set up it from our constant height, and there's a title. That will be a null pointer. Next, we need to handle it. Is it return actually point or that is return null? Let's handle it. If window equal null pointer, then let's in this case let's just like make standard output out fail to create window and line. Then let's terminate our glfw and let's exit program. I prefer that syntax, but basically you can use return -1, it will be the same. Yep, and last, what we need to do, glfw make current context and set up our created window before. Yep. Then let's set up some glfw option. That option will be we handle key callback here. Set key callback, and we basically set callback to another glfw function that called glfw set key callback. We set up a window pointer here and key callback here. Then let's actually start using OpenGL functions. And as you know, we will use not directly OpenGL function, but we will use through the GL library. Let's start in. First of all, we need basically set up that modern feature Leo experimental to true, and make some comment using turn self OpenGL. Then let's check if that okay or not after our initialization of GL library. Init, simple enough, just init, and let's gl ok, and if that succeed, we go. If no, we need to just we can make a console output to standard output cout it to init and line here and make an exit. This exit code failure. Okay. And then we need to define our viewport dimensions. Define viewport until okay, this is correct probably. Int basically it's very simple. glfw get frame buffer size probably, yeah, this is correct. Window pointer, let's put a pointer for width and pointer to height. GL viewport 0, 0, and actually our variables, not pointer. And actually we're ready to start our game loop here, and we will use simple construction while. I know somebody uses do while, but I prefer just while. For me it's most simple. While condition, if it's not GL FW window should close after completion, it's very nice, we know, and go to next line. And what we should do in this case, first of all, we should check any key press event Let's make a check if any events have been activated, like key press, mouse, and etc. Then actually let's do it. GL fw pool events. Then basically I need to render, but I do not have nothing to render right now. Render. Let's skip it. Skip for now. Then we need clear the color buffer, and basically I set up, because by default it will be black window, but I set up a little bit green window, GL clear color, and you will see green window instead, just noisy black window. 0.3 free float, and for alpha it will be just 1. And then we need last stuff, just gel clear and gel color buffer bit, and it looks like done. No, last stuff, it will be swap the screen buffers. Let's do it. Swap the screen buffers and GLFW swap buffers. Basically it's like state machine, state by state. And let's put it window pointer here. And it looks like done. Actually we can terminate here after while loop, GLFW terminate before actually return 0 for good manner. And let's actually define our callback function for handle user keyboards. Define yeah, we can just copy the signature, put it here. Sorry. And what we need, we can just print to console what key was pressed, cout key and line, and then handle escape key. If key equal glfw key escape, and if action if glfw press, and so in this case what we should do, in this case just like glfw set window should close window pointer from that function, from this callback function, and to true. And basically that looks correct. Let's try. It was failed. Failed to init glare. Yeah, it should be not equal. No, it should be correct. Yeah, here we go. We have a little bit green screen here, and that's enough for the So let's continue. Our next step will be actually to render some triangle to our screen. Yeah. For that step, we need few things. First of all, we need to render our shaders, and then we need to actually bind our data to graphic cards. So let's begin. First of all, I add a few variables here at the top of our C++ main file, and one more function prototype. So it will be gluint compile shader program. And that function prototype actually will be return shader ID, what we will use in our game loop. Next one, I'm gonna add our vertices. I can put it somewhere here, for example. Vertices. It's GL flow type. Where this array, and basically I just write 3-dimension vertices, but we will use only 2-dimension from that point. Minus 0.5 float, minus 0.5 float, 0 float. Next line, 0.5 float, minus 0.5 float, 0.0 float, and last line, last vertices is 0.0f, minus 0.5 float, 0.0 float. We don't use actually z variable in this topic. So next one. Here I need to add shaders. Basically, in real programming, we need to use separate files, but for simplicity, I will put all shaders as just a character array right here. So let's begin. And first will be vertex shader, and I can put const gl char. That is a pointer, of course. Vertex shader source. That is equal long string actually. So let's begin. First of all, we put the version. Then we need to put our attributes position here. Next line, we need to put main function. It's actually like C++ programming style that also has a main function. Of course, we need to reset, put end of line for each of that line. we wouldn't do this, it will throw the error. So we need to return GL position, and it's actually equals vector 4 position, and we ignore last parameter, don't need it right now, but I put 0.1f here, and we need to put end of line here. And last one, I need to close my curly braces right here, and for good manner I need to enter my C++. It's actually like C string. Okay, and put semicolon. What's the error here? I should remove it. Next one, it will be fragment shader, and it will be const GL char, of course it is a pointer, fragment shader source. That is equal also very long line. What should be first? Of course we put the version. Version will be of course the same. Next line. This line we need to put output. We need to somewhere in that string specify output, and for fragment shader output is the color, and it's vector 4, and this is a color, and right, yeah, I need to put end of string here, and the same, I need to put void main function, end of string, and 3 more lines. Start of our color braces, end of our function, and 0, and actually the code of our function. It will be a really simple function, just return a color, and this is vector 4, 1.0f. For example, we can choose any color what we like. Right now it will be just like a constant, we just put it here, our value. This is not dynamic right now, it's just a static color. And I need to end my line here, probably that's all. Yeah. What we should do next? Next we need to actually, yeah, for example, here we can define our variable. It will be compile shaders and GLUint. It's return shader program equals compile shader program. We'll define that function later. I'm only declare it here, and I will define it later in the bottom of that file. For now it's just okay. Yeah, it's an unused variable. Then we need to start working with our data actually and vertices. First of all, we need to generate vertex array and buffers. So this type GL int vertex buffer object and vertex array, and we generate the data vertex array 1, and we put a pointer Yes, we put pointer to array vertex array object, and second step we need to generate buffer. Gen buffers. Also one, we generate one buffer and vertex buffer object pointer. This function take a pointer. Next one, we need to bind vertex array. GL bind vertex. Yes, correct syntax. And actually, this is just a number, and OpenGL keeping track only numbers, not actually pointer, because it's cross-platform, simple for cross-platform solution. Then we need to bind buffers. It's GL bind buffer and GL array buffer vertex buffer object here. Next step, we need to set vertex buffer. Actually, in this function, not function, that macro, we pass to that macro our vertices, our actually vertices, what we defined here at the top of our file. GL vertex array. Oh, sorry, not that. GL bind data. Sorry, GL buffer data. Buffer data. Here, GL array buffer. Size of our vertices. Actually, we pass our vertices pointer right here, and we use GL static draw because it will be only static image, static triangle. Then we need to set attribute pointer. Basically, what we need to do, we need to put our pointer for each of our vertices from our vertices array to our shaders. You know, like we put each of the line to that line to our shader, and shaders on graphic card load step by step. Yeah, we will see later. I will show. Yeah, where I stop here. And what is this? Is GL vertex trip pointer? It's correct. Bit text 0, size of 3, GL float, GL false, 3 times size of GL float, and we need to put pointer to the GL void. We cast to GL void here, and we don't use any other data, for example, like color, normals, etc. So we put just 0 here. And we need to enable GL enable vertex trip array to 0. that 0 it's actually put it here to this location 0 in our vertex shader. So what should be next? Next we should unbind vertex array object and vertex buffer object gel bind buffers gel bind buffer gel array buffer 0 and gel bind vertex array to 0 as well. Yeah, so what we should do, it's mistake, it's correct comment here. Yeah, now we can actually draw our triangle right here. Draw a triangle, use program shader program. We use here program for draw that vertices depend to that shader and fragment program. On our graphic card, gel bind vertex array, we put to vertex array object. Then we need to specify how we want to write. How we want to draw. Gel draw array. The mode is gel triangles. Put 0 and we want to draw 3 vertices. And we need to unbind. Gel bind vertex array. Put it to 0. That's simple enough. And the last step, we need to deallocate resources from buffers. Gel delete vertex arrays 1 and we put a pointer. Gel delete buffers 1 and vertex buffer object here. So we're almost done. What we need to do next, last step, is actually to define that function for compile shader program. And just put it here. Yeah, and I can put some comment here for future references. Compile shader program and turn unique ID. So first of all, we need to have some logs. If that succeed or not, we need to see in our standard output logs. It will be a few variables here. Log size 512 gel int we actually will put to that variable success some data from during compilation and linking, and you will see later. Gel char and set that log variable. It actually storage for log data. we put the size. So we are ready to start render our vertex shader. Jelly int vertex shader equal gel create shader macro gel vertex shader. Then we need to put our source from our array of chapter. Gel shader gel shader source. Yeah, this is correct references. Vertex shader 1, and we need to put a pointer to our source, and last parameter is just null, and we need to compile it. Gel compile shader vertex shader. Then next step, we need to check for if that any error after compilation. Check for any gel get shader vertex shader log size. Oh no, sorry, not that. Where vertex shader gl compile status, and we need to put pointer to our success variable. That's done, and then we need to check if not success, then we need to put data in our log. Get shader info log vertex shader log size and pointer and shader log. What's wrong here? No, it should be just int. And last step, we need just print it to our standard output. Cout vertex shader der compilation failed. Yes, this is correct. Put some log here and line. Yeah, so that will be checked for any issue during compilation of vertex shader. So next step, we need to compile fragment shader. Basically, it's almost the same. I can just copy and pass it here and fragment fragment shader, and just replace our vertex shader for to fragment shader. Vertex shader compile status and fragment shader compilation failed. Looks like correct. So next step and almost last step is link shaders gel uint shader program id equal gel create shader program. It does not take any parameters. Gel attach shader program ID, a vertex shader, gel attach shader, fragment shader. Oh no, sorry, first parameter it should be shader program ID, fragment shader, and last step gel link program, and set macro take only one parameter, shader program ID. So here we also need to check for linking errors. Gel get program IV, shader program ID, gel link status, and last variable success or not. Then we need to check if that not success. Next we need to put some logs and print it. Gel get program log info log. This is correct macro. Shader program ID, log size, null pointer, and actually log, and put it to cout, standard output, if there are any issues during linking. Shader linking failed. Oh, sorry, it should be lowercase log and line. Looks like correct. So before the end of our function, we need deallocate resources. Gel the shader vertex shader, gel delete shader fragment shader, and last step we need just return our shader program ID. And is that correct? We should see nice orange triangle. Let's try. No, there's some issue. Let's check. Looks like not var vec3. One more issue here, looks like location. Fragment shader compilation failed. Fragment shader here. and of course it will be vec4. Looks like correct. Finally, I found the issue. It was a really simple issue. I just put it minus here, and my vertex was wrong, and it's cannot draw the 2D triangle, and I just remove minus from last vertices, save it, and run. And now finally we have nice orange triangle. Thank you.